On to question 5 now. We've got quite a long question here to do with differential equations. So this is a modelling context question for differential equations. So if we start at the beginning, what this question is looking at is a tank that's filling with water, and it can be modelled by this differential equation given here. So the derivative of s with respect to t is equal to 3 minus 2s over 100 plus t. So for part A, it's just asking how do we show that this situation can be modelled by this differential equation. So this is 4 marks for this. Now, I've jotted some notes here just so I don't have to write it all down as I'm going through, but I will explain in context what's going on in this question. So the first part here, so for a question like this, just read through it slowly and underline any bits of information that you think might be of use. So when reading this, the first thing that popped out to me was that the tank initially contains 100 litres of pure water. Okay, it tells us that salt water enters the tank at a rate of 3 litres every minute, and each litre of this salt water enters the tank contains 1 gram of salt. Now what we're also told is that the water in the tank flows out at a rate of 2 litres per minute. So it's telling us down here that a valve is open at the bottom of the tank and then the solution flows out at a rate of 2 litres per minute. So the first thing that this tells me here, okay, is that if 3 litres are entering every minute and then that 2 litres leave every minute, in total for every minute we're getting another litre, right? So after 5 minutes, we've got 5 extra litres in the tank. 10 minutes, 10 litres. So straight away, we know that the tank initially contains 100 litres. So we've got 100 plus t, right? Well, this is representing t minutes. So if we've got 5 minutes, we've got an extra 5 litres. So that's the first bit there. That's our 100 plus t. And notice we've got this 100 plus t in the differential equation. We also know that 2 litres leave the tank each minute. So we're going to work out the concentration now. So this is relating to this bit here. So we know that 2 litres leave the tank each minute. So that gives us the minus 2. And the concentration can be given as S here. So it's going to be S divided by the amount at, t minutes, for example, here. So it's going to be S over 100 plus T grams per litre. So we can put this all together now. We also know, like it says here, salt water enters the tank at a rate of 3 litres every minute. So this gives us the first bit here, the 3. So we can write the derivative here as being equal to 3, because it enters at 3 litres every minute for the salt water. And we're going to minus off this part here, the salt concentration. So that's minus 2, because we take out 2 litres per minute. So it's minus 2 times the concentration that we had here, which gives us our derivative here. Okay, so they're usually quite generous with these questions, these part A's, where you've got to explain the context of what's actually going on. So just jot down a few points, even if you really struggle with these questions, jot down a few points and then just try and put everything together. But it's just something that comes with practice. Definitely keep practicing more past paper questions if this is something that you struggle with. Okay, so let's move on to part B now. So let's jump into the maths of this question. So we have to actually find now the number of grams of salt in the tank after 10 minutes, and we've got this differential equation presented above. Well, we're going to have to solve this, and this is going to be a differential equation with an integrating factor. Okay, so before I can actually solve this, I need to get this in the appropriate form. So they've got it as ds is equal to dt. ds of dt is equal to 3 minus 2s over 100 plus t. But this isn't quite in the form that we would normally work for with a differential equation with an integrating factor. Remember, we need a d, so we've got this derivative at the front, and we also need the function that comes after in terms of s, right? So if we do that, what we'll have is we'll have d of s over dt. Now this is minus 2s over 100 plus t, so it'll become positive now. It's going to be plus 2s over 100 plus t. 100 plus t, like so. And this is going to be equal to 3, right? Now this is in a form that we can work with. We can manipulate this and we can work out our integrating factor. So before we work at the integrating factor though, just got to double check that the coefficient of the derivative is 1. And of course it's right, there's nothing in front of this. So we can jump straight into differentiating this now. So the integrating factor, remember, well, for this one, it's going to be e to the integral now of the 2 over here, right? This 2 over 100 plus t. So we're integrating 2 over 100 plus t because this is technically my coefficient now of the s. Okay, because this is 2 over 100 plus t times s. So we integrate whatever's in front of the s, which is 2 over 100 plus t. So that's the integral of that with respect to t. So what would that give us? Well, integrating this, what's the derivative of the denominator? That'd be 1. So what do I need to times that to get to 2? Well, I'd have to times that by 2, right? So it's going to be 2 ln of this here, my expression here. So that'd be 100 plus t. 100 plus t. What I should also have is this is equal to e to the power of this. And now, again, you can take your power across here like we normally do with these questions. You take your power across, so this is equal to e to the ln of 100 plus t all squared. And remember, just from your A-level maths, e to the ln, that cancels, and we just get left with this. So our integrating factor for this question is 100 plus t squared, okay? So 100 plus t all squared, like so. Okay, so we've got the integrating factor now. What we do next is we times through our differential equation by the integrating factor, okay? So let's do that. So if we do that over here, so we've got a bit extra room. So I have times everything through now. So ds by dt by the integrating factor, so do that. Oops, done it again. Keep doing this recently. So d of s by, in fact, I'm going to undo all that. That's not going to let me. D of s by dt, there we go, that's a bit better. Times by my integrating factor, so 100 plus t squared, all squared, sorry, all squared like that. Times this now by 100 plus t squared, but notice I've got 100 plus t on the denominator, so that'll cancel with one of them. So I'm going to get now 2s, plus s lots of 100 plus t, plus s lots of 100 plus t. Like so. And then my right hand side, 3 times this, we just get this, nice and easy. So that's that, all squared. Okay, so we've times all of it through now by the integrating factor. Now we need to integrate both sides. So, if we integrate both sides here, well, to do this now, what I'm going to do is I'm just going to do a bit of simplification, just so it's a little bit nicer to look at. So, if we do this, this will be d over dt. So hopefully this is rather straightforward. Well, we're simplifying it, so it's going to be 100 plus t. So this is a pretty standard question. This is very similar to a lot of the examples in the actual Edexcel textbook. So if you're unsure what this actually looks like, use the link in the description I provided below to look at the textbook examples. So if we do that, this will be equal now to 3 lots of this still, so this can't really simplify any further. Or we don't want to simplify it just yet. Plus t squared. Okay, so we integrate both sides. Well, I won't bother actually integrating it, because think about what's going to happen. If we integrate this side, well, this is the derivative with respect to t. Well, if you integrate the derivative, then you're just going to get left with whatever there is. And this side here, if we add 1 to the power and divide by the new power, we're just going to get left with 100 plus t cubed. So, if I integrate both sides now, so if I do the integral symbol and then what it will be, so I'm just going to get left with this here, so it's going to be 100 plus t all squared times by s. So 100 plus t squared times by s, and that's going to be equal to 100 plus t cubed. 100 plus t cubed, and don't forget your constant of integration, so plus c. Okay, so we're getting there now. All we've got to do now is use the initial conditions. But if you actually read this question, they don't give us any, okay? We're not given the initial conditions, so we've got to figure these out for ourselves. But think about what's actually happening in the question. What do we have when the time is equal to 0? Well, the time is equal to 0, so we take this up here now. So if t is equal to 0, equal t equals 0, what will s be? Well, s, that will also be 0, right? So, if we write this down, if t is equal to 0, then s will be equal to 0 as well. So now we actually do have the initial conditions. So, what I do now is I look here at my integrated function. So, if I put t equals 0 and s equals 0 into here, what do we obtain for c? So let's do that. Well, 100 plus t, so that would be 100 because t is 0, so that would be 100 squared, times by s, but s is 0. So we're just going to get 0 on the right hand side. So 0 is going to be equal. If I put t equals 0 in here, I'm going to get 100 plus 0 cubed. So it's going to be 100 cubed. So if I just write that down, 100 cubed, 100 cubed, and we've got r plus c, right? Well, therefore, c must just be equal to minus 100 cubed. We're just taking that 100 cubed across. So we get minus 100 cubed. Now this would be equal to minus 10 to the 6. Makes it a little bit nicer to work with. So when t is 10 now, because this is what we actually have to work out when t is 10, so we're not quite done yet. We just need to know when t is 10. So t is 10. So when t is 10, what are we going to obtain? So before I can do that just yet, I'm going to obtain s equals, because what we want to know is the salt, the number of grams of salt in the tank after 10 minutes. So I've got now s equals, so if I just do this down here, just so I can cut it off, so s equals, so it's going to be 100 plus t all cubed minus 10 to the 6 divided by this 100 plus t squared. So if I just write that out so we can see, so all I'm doing is rearranging this here, this integrated function in terms of s. So s equals 100 plus t all cubed like so. I'm going to minus my 10 to the 6 minus 10 to the 6 all over 100 plus t squared plus t squared. Okay, now because I'm running out of room, I'm just going to kind of skip to the working. So what you should get is 27, or I'm just going to skip to the answer, sorry. You should get 27.4 if you're doing it to 3 significant figures. There's no accuracy provided, so I just do something sensible like 27.4, but it's completely up to you, seeing as there's no rounding accuracy given. So 27.4 to 3 significant figures, so that's 27.4 grams. And there we go, that's part B fully done. So moving on to part C, we've got our formula for S, and part C is asking us to find to the nearest minute when the valve would need to be closed if the concentration of the salt in the tank reaches 0.9 grams per litre, which is the valve at the bottom of the tank must be closed. So, how would we start this question? Well, we're looking at the concentration here, right? And this is the formula we've got that we've just used from part B. So, what we're looking for is my S, and don't forget, we divide it by 100 plus T. So, I know it's minus 2S here, but this is only because 2 litres are leaving per minute. So, ignore the minus 2 for now, it's just going to be S over 100 plus T. So, we're going to have to divide this by 100 plus T. But before I do that, I'm just going to simplify this a little bit to make it a bit easier to work with, right? So, I can split this into 2 fractions, right? So, it's going to be 100 plus T cubed over 100 plus T squared minus 10 to the 6 over 100 plus T squared. So, what I'm going to get left with is just one lot of this on top, because that'll cancel, the 2 will cancel with the 3 T, and just 1 up here, a power of 1. So, this will be 100 plus T, like so, 100 plus T. Now this will be minus 10 to the 6 over this, minus 10 to the 6 all over 100 plus T squared. 100 plus T squared, like so, right? So this is the exact same thing, it just makes it a little bit easier to work with for this question. So now we need to do S divided by this. So we're going to divide this by 100 plus T. So, if we write this out, what this will be is 100 plus T minus this again. So minus 10 over 6, sorry, minus 10 to the 6 over 100 plus t all squared divided by 100 plus t. Okay. So divided by 100 plus t. So where do we begin with this? Well, this would now be the same as me having 1 over 100 plus t times by this, right? Just using the rules of, division of fractions and division of numbers, right? So what can I do here? Well, I'm going to write out like that just 'cause I think it makes it easier personally for me to see. That's how I prefer to look at it. But it's completely up to you. As long as you can manipulate this, then you can do it in whichever way you find it easiest. So if we write that out, let's do that. So it's going to be 1 over 100 plus t. So that's a 0. 1 over 100 plus t times, so we're timesing it by this now, because this is 1 over, so 100 plus t again. So I've seen enough of 100 plus t now, it's getting kind of annoying. Minus 10 to the 6 all over this again. So 100 plus t squared, it's getting rather irritating now, we've seen it quite a bit. 100 plus t all squared, like so. And this is going to be equal now, so this is when it's equal to 0.9, okay? This is equal to 0.9. So now, we've got this expression here. All we've actually got to do now is just times through by this denominator here, 100 plus t. We times this side by it, we're just going to get left with this. Now we times this side by it, we're going to get 0.9 lots of it, right? So, let's do that. I'm going to do it over here for a bit of extra room. So, if I times this side by 100 plus t, then I'm just going to get 100 plus t minus 10 to the 6 over this. So 100 plus t, 100 plus t minus 10 to the 6 all over 100 plus t squared. Like so. And my right hand side will just be 0.9 times 100 plus t. So 0.9 times 100 plus t. Okay. Now we just need to keep simplifying here and working towards a value. So what can I do next? Well, I can just times through by this denominator again, right? Times through by denominator again, and we'll keep simplifying so we can get this value for t. So timesing through by this now, 100 plus t all squared. Well, 100 plus t times this, I'll get 100 plus t cubed. So now I've got 100 plus t all cubed. All cubed. This will be minus 10 to the 6, because this will just cancel with the numerator. Minus 10 to the 6. Oops, that's quite a big 6. There we go, minus 10 to the 6. Now this side will be equal to 0.9. Like we did here, because this is a power 1, this is a power 1, we're going to get 100 plus t cubed. So 0.9 lots of 100 plus t, oops, 100 plus t, and I can get my pen back, 100 plus t all cubed, okay? Now we just need to keep simplifying. So I'm going to take this 10 to the 6 across here, so it becomes positive, and I'm going to take this 0.9 lots of this across, because this is one lot of it, this is 0.9 lots, we can just subtract it. So 1 lot of this minus 0.9 lots of it, so I'm going to get 0.1. So 0.1 lots of 100 plus t all cubed. This is going to be equal to 10 to the 6 now. Okay. Again, let's keep simplifying. I can now divide both sides by 0.1. Well, divide this side by 0.1. This will just be 100 plus t cubed. This side, if we divide it by 0.1, this will be t to the 7, right? The power will get bigger. So 100 plus t to the power of 3 will be equal to 10 to the 7. Like so. Now we can take the cube root of both sides. So if we do that up here, the cube root, so I'm going to get 100 plus t, nice and easy. Take the cube root of this side. So for now, I'm just going to keep everything in the exact form and then just give the final answer. So 100 plus t, this is going to be equal to the cube root of 10 to the 7. 10 to the 7. Like so. And now, all we've got to do is minus 100 off this. So therefore, t is equal to this minus 100. So if you put this in on your calculator, so if I just quickly do this, see what I get. This will give us, so the cube root 10 to the 7 minus 100. So this gives us 115.44. Okay, but because it's to the nearest minute, make sure you give this to 116 minutes. And there we have it, that's part C done. And then finally for part D, it's just a 1 marker. If you ever get a question like this for a modelling question where it says evaluate the model, it's kind of just asking, is there a flaw or a limitation with the model? So for this question here, there's a couple of things you could put. I probably think the best comment, or the one that came to me first, was the fact that the model is not going to be valid when the valve is closed or shut, right? The model doesn't hold. So that's the first thing you could say. Or you could also say the concentration is unlikely to remain the exact same, you know, for each minute that this operation is running, this tank is flowing. So a couple of comments you can make. There's even more on the official mark schemes, but them are just like the two that I think are, you know, the most obvious. But yeah, that's question 5 fully complete.